Bohr's correspondence principle. Part A showed that in the Bohr model, the frequency of revolution of an electron in its circular orbit around a stationary hydrogen nucleus is F is equal to m e to the fourth power divided by 4 epsilon 0 square n cube h cube. Okay, so let's remember the Bohr model. We have the hydrogen nucleus here, which is positively charged. The electron is orbiting around the nucleus, performing uniform circular motion. For the nth orbit, it has a radius r sub n, its velocity, tangential velocity, v sub n. According to Bohr's postulates, one of the postulates is that the angular momentum of the electron, p theta, is equal to the mass of the electron multiplied by the velocity of the electron multiplied by the radius of the nth orbit. This is by definition the angular momentum, is equal to integer multiples of reduced Planck's constant and h bar. Okay, so that's a Bohr postulate. Now, looking at the uniform circular motion the electron is performing here, we realize that the tangential speed it has, v sub n, is related to its angular speed, omega multiplied by omega n multiplied by r sub n, the radius, which is equal to omega angular speed or angular frequency is 2 pi times the frequency, 2 pi f sub n times r sub n, so that the frequency of the revolution can be written in terms of the speed, tangential speed, v sub n divided by 2 pi radius of the orbit r sub n. The centripetal force that is responsible for the uniform circular motion, this centripetal force here, is due to Coulomb interaction between the electron and the positively charged nucleus. It is 1 over, given by Coulomb's law, 1 over 4 pi epsilon 0, permittivity of free space. The product of the charges, which is because the electron is charged, electron charge and the proton charge are the same but with opposite signs, it's e squared divided by the distance between the 2 point charges squared, r sub n squared. This is equal to mass times the centripetal acceleration, v sub n squared divided by r sub n, the radius of the orbit. The radius of the orbit cancels one of the r's on the left, and we are left with 1 over 4 pi epsilon 0 e squared is equal to mvr, which is the angular momentum, multiplied by v. You can see we have mv square r, but mvr times v is the same thing, and this term in parentheses we recognize as the angular momentum. So we can write v sub n, the tangential speed, as e squared over 4 pi epsilon 0 and it's divided by the angular momentum, but the angular momentum is equal to nh bar according to Bohr's postulates. So this tells us that the radius of the orbit is equal to nh bar divided by mass times its tangential speed. So that is r sub n is nh bar divided by mv. And here we can substitute for B the result that we have just found, E squared over 4 pi epsilon 0 NH bar. So we will get for 1 over V 4 pi epsilon 0 divided by E squared 4 pi epsilon 0 NH bar divided by E squared. But here I have mass times that, so this is going to be m E squared. And then I already had an NH bar here, so NH bar will be multiplied with this NH bar. So I will have n square H bar squared. So let's check what I did here. NH bar over m multiplied by 1 over v. 1 over v is 4 pi epsilon 0 NH bar, so I will have 4 pi epsilon 0 NH bar parentheses squared divided by E squared multiplied by me squared. Okay, now the frequency is the tangential speed divided by the tangential velocity magnitude divided by 2 pi times the radius of the orbit. So I can substitute that here. I will obtain the frequency for the nth orbit is equal to E square over 4 pi epsilon 0 NH bar, that's the velocity, divided by 2 pi Rn. So Rn is here. So we're going to take the reciprocal of this. Me squared over me squared over 4 pi multiplied by 2 pi, 8 pi squared epsilon 0 n squared h bar squared. So this is going to give us m multiplied by electron charge to the fourth power. Then I have 4 pi epsilon 0 n h over 2 pi, 4 pi epsilon 0 n h divided by 2 pi, 4 pi epsilon 0 n h bar, 8 pi square epsilon 0, 8 pi squared epsilon 0, n squared h bar squared, which is h squared over 4 pi squared. Now you can see that this pi square will cancel this pi squared, and 2 times 4, 8 will cancel this 8, and then I will have 1 pi disappearing from this one. So I will be left with the following answer. The frequency for the nth orbit is mass times electron charge to the fourth power, me to the fourth power, divided by 4, all the pi's were cancelled. For epsilon 0, I had 2 epsilon zeros here, so it's epsilon 0 square. And then I had n square and n, so this is going to give me n cube, and I had an h square Planck's constant squared times Planck's constant, so it is h cube. So the frequency of the nth orbit is given by this expression. So let's check the suggested answer. Me to the fourth power divided by 4 epsilon square, epsilon 0 square, n cube, h cube. So we worked with Bohr's model. The angular momentum is quantized in units of h bar. There is the uniform circular motion. The tangential speed is angular speed times the radius of the orbit, where the angular speed is the angular frequency, 2 pi times f. And the Coulomb force K Q1 Q2 over R squared, K is 1 over 4 pi epsilon 0, Coulomb's constant, E squared over R squared, because the nucleus has plus E charge, is equal to mass times the centripetal acceleration mv squared over r. So from this equation, recognizing mvr is nh bar, we obtain v, and then r is equal to nh bar over mv. So we substitute for v this expression, so we find r, and the frequency is v over 2 pi r. So we substitute v and r that we have calculated here to this expression and find that the frequency of the nth orbit is indeed given by the suggested expression.